Okay, so this is section 2.5, unions and intersections of figures. Okay, so a couple of definitions there to start. So union of two sets and intersection of two sets, both on page 83. So if you flip to 83, write those down. So it says the union of two sets AB is written as A and then a little U shape and then a B. And what it means, it says, is the set of elements that are either in A or B or in both. Okay, so union basically means everything. Okay, now intersection. So the intersection of two sets, A and B, is written as, and then they take that symbol and flip it upside down, kind of more like an N. So union U shape, intersection N shape. And that says is the set of elements that are in both A and B. Okay, so union is everything, intersection is where they cross, or both. Okay, so some examples of both of these in different forms here. So the first examples here are Venn diagrams. So intersection for your Venn diagrams would be where these two circles cross each other. Okay, so that middle part. And then union would be everything in A, everything in B, and then also what's in the middle of there, what's in both. Okay. Now you also might see this as lines. Okay, so the intersection of these two lines here, M and N, would be this middle point, P, because that's where those two lines cross. So that would be their intersection. Okay. Now, if they want the union of two lines, basically they want everything in one line and then also everything in the other line. So we've got the union of the rays SQ, so from S through Q forever. Then also the ray SR, so from S through R forever. So total, the union of those, so this one and this one together, would be the angle QSR. Okay, so union, both of them together, intersection, just where they meet, or where they're the same, where they cross. Okay. You also might see these in sets of numbers. So the intersection of these two sets of numbers, so the first set is 3, 4, and 5, and then they want the intersection of that with 4, 8, and 3. Well, the things that are in both intersection would be the 3 and 4, 4 and 3, so the intersection of those would be 3 and 4. Okay. Now union, on the other hand, is everything that's in both groups. Okay, so the union of the set 3, 5, 9 with 2 and 4 would be everything that's in this group, everything that's in this group, so 2, 3, 4, 5, and 9. Okay, intersection where they cross, union is everything. Okay, so first example here says given the line FD, so let's find my pen. So FD, if I draw this out, I've got a line, put a point D on it, put a point F on it, and then it says the point E is in between there. Okay, so E is in the middle. Alright, and then we are supposed to, for the first part, we're supposed to figure out the union of the segment ED and EF. Okay, so the segment ED would be that chunk right there. The segment EF would be that chunk right there. So if I want the union, I want both of those together. So if I take everything that's in the pink, everything in the blue, and combine those together, I'm basically getting a bigger segment then. So my union of the pink set and the blue set would be the yellow set. So my union would be the segment DF. Okay, because that's including everything that's in the first part, everything that's in the second part. So all together, it would be the segment DF. Okay. Now the next one here, they want that same line. So we've got the line DF, so D there, F there, E is still in the middle. This time they want an intersection, so this time they want the intersection of DE, so D and E, or D to E, and then DF, so if we go D to F for that one, they want to know where those two cross because they want the intersection. Well, the spot where those two are the same would be just the part here, D to E, right? Because that from there to there is the only spot where those two are both exactly the same. So our intersection here, where they cross each other, would be the segment DE. Okay, so that's different from this one because with union, they want everything. With intersection, they just want where they cross. Okay? Okay, next thing here. We've got union and intersection in polygons. Okay, so they give us a triangle, A, B, C, and then they say that the triangle, so ABC as a triangle, is made up of the segment, and I'll mark this out here, the segment AB, so that one there, and then union with BC, that one there, that segment, and then also CA. Okay, and if you think about it, if you take those three segments, so AB, BC, and CA, and combine them all together, so union all of them put together, that would make a triangle, right? So you can do that with any polygon. So say you got a pentagon or something like that. If you take the union of all of its sides together, that makes a full polygon, okay? And when we write down the definition of a polygon, which I believe is in the next section, that's exactly what the definition is. It's talking about unions in polygons, okay? Next thing here you might see is called an empty set. So what it is, and they kind of show you an example here. So if we've got the ray FL, so starting at F going through L forever in this direction, and they want the intersection of that with this segment MN. Well, we know segments have two stopping points, right? So it's stopping at M, stopping at N, and with our ray, it's got one stopping point here at F, the end point, and it's going through L forever, but that line L is never going to circle back up here to this MN segment. So what we do is we call this a null set or an empty set. Okay, so basically it's a set that contains no elements or nothing works for that. Okay, so the intersection of these two things that are never going to cross each other can either be written as curly brackets like that, just with nothing in them, or you can put a 0 with a slash through it. Okay, both of those mean empty set. Okay. Alright, the next thing here, we want to look at an example that's in the book. So if you look on page 85 in your book, they have a subway system. So it says, consider the Washington, D.C. subway lines on page 85. R stands for red, B blue, G green, O orange, and Y yellow. Okay, so they want to know what does the union of R, B, and Y mean. Okay, so if we look at our subway here, they want to know what the union of R, B, and Y is. Okay, well, R is all the red lines, B is all the blue lines, and Y is all the yellow lines, right? So really, the only ones they're leaving out are the orange ones and the green ones. Okay, so what we could say here for our answer, what does that mean? Well, it basically means the entire subway system except for the parts that are only green or only orange. Okay, so we could put the entire subway system except the parts that are only green or only orange. Okay, because the rest of the subway is either red, blue, or yellow, and we want all of those together. Okay, so the next thing for B says how many stations are served by the sections contained in the intersection of Y and B. Okay, so intersection of Y and B would be the crossing spots of the yellow and the blue. Okay, and then each of the white dots is a station. So if we go back here to our subway, we basically want the stations, or the white dots, that are where the yellow and the blue lines cross each other. Okay, so if we look here, well, there's a long stretch right here where the yellows and the blues cross. So that would be 1, 2, 3, 4, 5, 6. So all those different stations there. Then there's also a station right here that's crossed by a whole bunch of them. So yellow, green, blue, all of that. So that's another one right there. So total, we'd have those 6 and that one there. So total, the intersection of those two lines would be 7 different stations. Okay, so for B of this, we can put 7 stations. Okay, so that's all for the notes. So the assignment that goes with this section is page 86, 1 to 3, 5 to 12, and then 14, 16, and 18. Okay, so all of those, 1 to 3, 5 to 12, and then 14, 16, and 18.